Hey everybody, it's Mr. Friday, and I'm out today, but I want to make sure that I do everything that I can to make sure that you understand the science behind asteroid problem solving. And so the article that you read during the first half of class and the TED Talk by Carrie Nugent titled Adventures of an Asteroid Hunter were sort of a preview of us sort of reasoning through what some plausible and implausible solutions are for dealing with near-Earth asteroids. And so let's go ahead and write down a definition. You can follow along and write on your paper that you picked when you walked in. So what are near-Earth asteroids? They are asteroids that have orbits that cross Earth's orbit. And we could get even more specific than that. The particular asteroids that we're really more worried about than others are those that get within the orbit of the moon. And that's about 235,000-ish miles, I think. And recently we just had an asteroid, sorry about the bell. Recently, we just got an asteroid that came within the orbit of the moon, but it missed us. And the key thing for stopping asteroids from hitting Earth is early detection, because the biggest threat of a near-Earth asteroid is when we don't detect it in time to do something about it. And so most of NASA's efforts over the last several decades or so have been about better detection. And the good news is that as our technology improves, we are getting better and better at detecting asteroids early, and we are currently tracking thousands of objects that are in orbit around the sun that are potential near-Earth asteroids. And the good news is once we identify an object, we can do a really good job of calculating where it will be at any time in its future orbit and whether that will bring it on a possible collision course with Earth. Now, let's spend a little bit of time talking about consequences. What could happen to Earth when a near-Earth asteroid's orbit gets close? And so you can see that I have several different diameters here. We have an asteroid diameter of 30 feet, of 3,300 feet, and of 32,000 feet, and approximately how frequently they strike the Earth. And so about every 50 years or so, we get an asteroid with a diameter of about 30 feet or so, or around that size, striking Earth. And these are averages, by the way. It can be in less time than that. It can be in greater time than that. And of course, since the surface of the Earth is, the surface area of the Earth is mostly water, most asteroid impacts are most likely to occur in water. Now, that can produce tsunamis, and so we should definitely add that for our global consequence. Tsunami could be a global consequence for any of these three that are listed here. But then specifically for asteroids within this range, it will tend to level trees, it will tend to break windows, okay? And there's a specific example that I want to show you here, and so please bear with me while I switch to the Tunguska explosion in 1908 in Siberia is a really good example of an asteroid impact that happened over 100 years ago in Siberia. And as we have further studied this is a photo that was taken in 1927, but Siberia is a very, very remote place. And so when the photographer got there in 1927, this is a picture of a forest that was completely leveled by the Tunguska explosion. And that was an asteroid that was moving about 12 miles per second, and it gradually vaporized as it entered the atmosphere. But the big consequence of this is that it leveled trees, and it broke windows in communities that it got close to and really rattled a lot of people. But that's actually a fairly frequent occurrence if an asteroid were to get near Earth. And you can just Google on YouTube asteroid impact, and you got to be careful. It should be from a trusted space science source. So for example, this website is astronomy.com, so it is definitely trustworthy. So what about asteroids that are 3,300 feet in diameter? They impact Earth about every 500,000 years. Well, they leave big craters, like really large craters, like craters that are multiple dozens of miles across. And these are the types of asteroids that can have big environmental impacts on Earth. And the big thing that is happening there is that there are usually sediment from the ground and particles of the asteroid itself that shoot up into the atmosphere and can have the effect of influencing weather patterns and even blocking out the sun. And that can potentially even induce ice ages on Earth. And so one of the ways that we know when asteroid impacts have happened on Earth, and this is a good follow through after our plate tectonics unit, is that there are particular elements, especially iridium is a big asteroid marker. Iridium is element number 77 on the periodic table. It is a transition metal, but it is very commonly found in asteroids, and we can find layers within the rocks all around Earth that shows when asteroid impacts occurred because there are greater concentrations of iridium in the rock at those particular times. Now, you get an asteroid that's like 32,000 feet in diameter, which you're talking about an asteroid about 6 miles across. That's when we start getting mass extinctions on Earth. And the last mass extinction event that happened on Earth was when a big asteroid struck the Yucatan Peninsula in Mexico. We know exactly where it struck and with what force it struck and the crater that it created. And that is likely one of the factors that contributed to the global extinction of dinosaurs. Current evidence is suggesting that it probably wasn't the only factor, but then again, those factors could all be related to each other. You have a 32,000-foot asteroid striking the Earth, and it sets off this cascade of problems that just build and build on themselves until you get an entire phylum of species. Well, maybe not phylum, maybe an order that goes extinct. And so this leads to our next part here. How might we actually stop a collision? And it's good for us to do a little bit of brainstorming under these circumstances. And so what I'm going to ask your guest teacher to do is to write your ideas on the board first and then compare them to the ideas that I'm going to show in the video. And, you know, many of you are going to have great ideas and it isn't going to be too surprising, but I want you to see your ideas reflected in the video too. And so guest teacher, if you wouldn't mind pausing the video and just lead maybe like a 5-minute brainstorming section in which students propose ways in which we might stop an asteroid from colliding with the Earth, and maybe just, you know, bullet some titles, and we'll compare it to the list that I'm going to present here, as well as some pros and cons of each method, because there is no single perfect method of stopping asteroids from striking Earth. As you saw in the article, or as you read in the article during the first part of class, early detection is actually the most important thing that we could be doing. But how might we stop a collision? So thanks for pausing the video. And welcome back. So let's get some methods away. Let's start with what is most likely the most popular method for most people, and that is, well, why don't we just do what I've seen in movies and blow it up? And I'm going to go ahead, if you said nuke it as an example, that would be another thing, you know, that we could do. Well, there are lots of problems with blowing up asteroids or nuking asteroids, and I'm going to start with probably the simplest con that we have of those methods, which is that we don't really know how much explosives are needed. Even if you know the mass of the asteroid and a little bit of its surface composition, you don't necessarily know what its internal composition is. And as a result of that, we run into this whole host of problems that is related to blowing it up or nuking it. First of all, and we're going to focus this on quarter 3, we have Newton's first law of motion, which can be summarized as objects in motion tend to stay in motion, objects at rest tend to stay at rest. If there's an asteroid in an orbit around Earth that is on a collision, or an orbit around the sun that is on a collision course with Earth, the odds of us slowing that orbit down significantly with either combustive materials or nuclear materials is very, very small. In other words, you run into the problem where even if you succeed in blowing it up into other pieces, then you suddenly have thousands of little pieces moving towards Earth. So you basically have one object that was moving towards Earth, and now you have thousands of objects moving towards Earth, okay? And so you actually really haven't solved your problem. You've just actually made it worse, okay? And even worse than that, if you nuke it, then all of those thousands of particles are radioactive, okay? Which is even worse in of itself, okay? There actually really aren't any pros associated with attempting to blow up an asteroid. Most space scientists don't even consider it as an option because the realities of how physics work make it just a very, very bad idea. Now, don't get me wrong, it makes logical sense. And if you proposed it, you are exercising your logic. But remember, from a scientific perspective, we can make logical suggestions for things, but then when we think about what the laws of physics are, what the reality of a situation is, we always have to change our suggestions in light of new evidence, okay? So what about next? Well, one thing that has been proposed is the kinetic impact method, okay? This is also known as the space bullet method. And the idea behind the space bullet method is that you would not want to blow it up, okay? But to hit it with something that changes its orbit, okay? And don't get me wrong, this does have its positives as well. Let me just change my type size so that everything fits on here, okay? The pro is that if you can get it into a new orbit, it misses Earth, yay, okay? The problem is that we are right back to what we have above, is that if you don't hit it hard enough, if the hit is too weak, okay, you just end up with the same problem, Newton's first law. And since it is so difficult for us to recognize the amount of explosives or nuclear material that would be needed to truly deal with an asteroid, we run into a lot of problems real fast. Okay, I know that I'm using up more space than it was what is present on your sheet, but that's okay. Another possibility, and I'm just going to go ahead and hit enter here so it's fully on the next page for me. You can write on the back if you want to. Another thing that has been proposed is a gravity tractor. A gravity tractor is basically where you orbit a massive enough object around another object like an asteroid, and the pull of the gravity of the object that you are orbiting around the asteroid pulls on the asteroid enough to shift its orbit so that it does not miss Earth. And there are lots of pros for this. A big pro is that it's easy to do and launch. We already have the technology to do something like this, and it would probably have a very high success rate because really all you are doing is using your understanding of Newtonian gravity to shift an orbit of something. And we measure this with asteroids being influenced by the orbit of Jupiter is probably the biggest thing that influences asteroids in our area. Jupiter's orbit is likely what put Theia on a track to collide with Earth and form our moon, as we discussed earlier in the year. There are some problems. Major problem with this is that you need an object that is massive enough to actually make a difference. And that might be a problem depending upon the size of the object. A gravity tractor would work a lot better with a smaller object. It would be a lot harder to do with another object, but it is definitely a better option within our goals that we've set out for ourselves. Okay? Next, what about landing something on it? Okay? And the key example of this would be like little rocket engines, okay? And the problem with, well, first of all, the benefit of landing on something is that it would provide, I'm not getting, there we go. It would provide the force to shift the orbit. Okay, the big problem with landing something like rocket engines on an asteroid is that, one, it's difficult to land stuff on an asteroid. It's probably getting easier now than it's ever been with recent Mars missions that have occurred, but it still is a really difficult prospect, and if we had to do it quickly, it would be a real challenge to do it and guarantee that it was successful. And then we have a second problem that you would need to do it lots of times. You would need lots of rockets probably to get this to work. And so landing something on it like rocket engines is a logical idea, but it isn't something that we're really planning on too much because of those problems, the cons that you have. And then this is probably the one that throws most people for a loop that they don't consider, and that is heating to produce a spin. Okay, this is definitely something that we could do. Okay, the purpose of heating to produce a spin is that you can alter the orbit due to the angular momentum change. I can do this. Folks, you don't have to get the exact words down for everything if you get a sense of what's going on here. The problem is that you have to launch close enough to focus solar energy. Okay, I need another one here, so I'm gonna make this smaller. Okay, and then 2, you need to heat it enough and long enough to make a big enough change. And the problem with this method tends to be that you will heat it for enough to shift it into a new orbit, but the orbit is so similar to the old orbit that it ends up just setting it onto a future collision course with Earth. We would want a permanent change in an orbit for that to happen. So what is the best option here? Probably gravity tractor is probably the best option, but the problem with that option is that you need an object massive enough. And then the second best option is probably heating it to produce a spin, but this is why early detection is so important. You have to detect it early enough that you can prepare and launch a mission and heat a side of the asteroid to get it to start spinning, to shift its orbit. My apologies for the bell. Okay? And so the point here for today is that I want you to understand that there is complex science that goes into, and planning that goes into, dealing with potential asteroid impacts with Earth. This is not something, an issue that we're ignoring. NASA and other space agencies throughout the world have recognized that this has been a potential problem for a very, very long time. And there are people everywhere whose job it is to prepare and prevent potential asteroid impacts with the Earth. So the key, once again, is early detection, and advancements in technology have made that early detection a lot better, and advancements in technology have made options for dealing with a potential asteroid impact a lot better. But this is a fun way, I think, to kick off our space science unit, because not only does it show us using our existing understanding of gravity, but it also foreshadows what we're going to learn about Newtonian mechanics, Newton's laws of motion, in the future. And this is going to lead us into a study of how understanding light waves gets us to detect asteroids in the first place and other objects out in space in the first place. So at this point, guest teacher, thanks for displaying this video to students. Students, you have free time for the remainder of the mod, and this might be a good opportunity for work on any work that you have for class for natural science or for other classes. Expectations for free time is that you must remain seated in a chair, you must remain quiet and following all school rules. And so I will see you all again on Friday for large group. Have a good day, everybody.